Hello, in this video I will do an IBEW algebra and function practice test, and then this is practice test mode 3. So this isn't time, so I'm going to take my time, and yeah, let's begin. So IBEW algebra and function practice test number 3. Okay, well, let's begin. So as you can see, we have 32 questions, and it is time, but I'm going to take my time. So let's start with question 1. So question 1 says, which graph represents the following tables of values? So what I would do is they give you a table or coordinates, as I like to say. So let's write down my coordinates. So, and then we'll figure out which of these coordinates goes with the correct graph. So my first coordinate could be expressed as -2, 12. Next one is -1, 3. Next one is 0, -6. The next one is 1, 9, 1, -15. And the next one is 2, -24. Okay, so is it the first one? So be careful. This is how they are tricking you. This is not zero. So if look at the graph carefully, here's the x-axis and here's the y. So this is not zero. Usually this point is aligned to the zero, but in this is where the x value 0 is. So do we have an x value 0? Yes, we have a coordinate as 0, -6, and then on the y-axis, it's not by ones. This one right here, this one looks good. It looks like it's at 0, -6. See, this point here is -7, so that works. Now let's test some other points. So -2, 12. So here's -2, and then my y value should be 12. That's good. -1, 3 is right here. Okay. Let's test a few more. 1, -15. Yes. And then 2, -24. Yes. Here's 2. Here's 1. Yes. So this looks like it's the best because it satisfies all of these coordinates. So I'm going to say A. Okay. So this one, don't waste your time. Just get the points from the table. Decide which graph is the correct. Decide which graph has those points. And that we conclude that it is graph A. Okay. Correct. Okay. Move on to question 2. Okay. Question 2. Here we have several linear lines. We have line A, line B, line C, line C, line D. They're all linear, but they specifically says which function is depicted by line B. So this here is line B. I don't know if you can see this, but you can see the red line right here. This is line B. And what we got to do is find the equation of line B right here. So we got to find the equation of line B. So what do we know about linear lines? It's usually in the form of y equals mx plus b. If you look at this graph carefully, keep a note, here's our x, here's our y, and they're not going by ones. You have to understand that they're not going by ones. If see here, what are they going increments by? On the x-axis, I think they're going by halves, because this right here would be 1/2, and then this one would be 1, and then this is 1.5. So yeah, so they're going increments by 0, 1/2. So do you think in line B, do we have the y-intercept? Yes. What do you think my B value is? So look at the y-axis, and if we're going increments of 1/2, that means this one right here, that's my y-intercept, and I believe our B is going to be 1/2. So we could say 1/2 or 0.5. What about my slope? So we need the slope. We already have the b. Well, we know it's positive because it's going to the right. What else? So we know, could we, should we find the actual points? You don't have to if you don't want to, because this is where we could do some elimination. So what we know in line B, it's going to be positive. Your slope is going to be positive, and our B must be 1/2. Okay. So let's look at our option because we don't have to figure out the exact, we don't have to find everything. We just need to find the first, the one, yeah. So let's look at choice A. So in choice A, it's not really in the form of y equals mx plus wave. Let's get y by itself. If I get y by itself by dividing both sides by 2, I get y equals 2x, and then there's no b. So is this our graph? No. The reason why is because our b specifically said was 1/2. Our b does not go through the origin, so it can't be this one. What about the second one? We have y equals, see how they're trying to confuse you? It's, you can also rewrite this as y equals 4x minus 1. Is this the graph? Well, the slope is 4, which is positive, so that's good. So it could be. But they said that the b is -1. Our b is positive 1/2. So this is wrong. Okay, what about C? So you have to kind of get y by itself. So I'm going to divide both sides by 2, or everything by 2, not both sides. So you get y equals, and then 2x divided by 2 is x, and then 1 divided by 2 is 1. Okay, so my slope is technically 1, right? There's an invisible 1, which is positive, that's good. And then our b is 1/2. I think this might be it because our b is 1/2. You know, we don't know exactly what our slope is, but we do know it is positive. So 1 is technically positive. So maybe, right? Maybe. Let's look at the last one. Well, the last one, let's get y by itself by dividing everything by 2. So I get y equals, this is going to be 1/2 x, and this is going to be 1. No, even though the slope is 1 positive 1/2, that's good. But my b specifically has to be 1/2. So this can't be it, and this is the best choice. Okay, so let's try. Correct. Okay, let's move on to 3. Question 3. What is the next numbers of the following series? So now we're dealing with sequences, and so when we're dealing with sequences, you either have a common difference or a common ratio, right? So when I say common difference, so here, let me show you. Let's call 7 A1. What A1 means, it just means first term. And then let's call 25 A2, which means second term, and then 43 A3, etc., right? And then what we got to do is find the fifth term, right? So let's see if we have a common difference. So from 7 to 25, what did you have to add or what did you have to subtract? It looks like you had to add 18. And you can just do, to find the difference, you could just take the second term minus the first term. Okay, so that's how I got 18. Now, what about 25 to 43? What did you have to add or subtract? You definitely had to add 18. Okay, so it looks like it might, our sequence might have a common difference of 18. Keep on going. From 46, 43 to 61, what did you have to add or subtract? Positive 18. Okay, So it looks like we have a common difference of 18. So to find the fifth term, all you gotta do is take the last term, which is the fourth term, which is 61, add 15, because our difference is consistent. And 61 plus 15 is 79. So it looks like our choice is 79. Correct. Okay. Now, sometimes it won't be this easy. You might have a common ratio. You might have an alternating where it either changes from a difference to a ratio. So, yeah, let's move on to question four. It's another sequence. So our sequences are 51, 44, 37, 30, and 23. So let's look at first term. Just- So yeah, let's look at our first term. So this is my first term, second, third, fourth, fifth. We'll probably have to find the sixth term. That's what they really want. So let's ask ourselves, will we have a common difference? Or so from 51 to 44, what did you have to add or subtract? Um, I think you had to do a subtract a difference of -7, right? 51 to 44, we subtracted 7. And then from 44 to 37, what did you have to have or subtract? It looks like it's also -7, right? 44 minus 7 gives you 37. What about 37 to 30? Yes, you definitely had to subtract 7, and then from 30 to 23, you also have to subtract 7. So this concludes that we have a common difference of a -7. So to find the sixth term, you take the last term, which is 23, and then minus 7. And it looks like it's getting 16. Okay. So this 3 and 4 weren't too bad, right? Let's move on. What is the next number in the following series? So question 5. So 3 is like my first, 5 is your second, 9 is your third, 17, 4, 33. So what we got to do is find the sixth term. So let's see if we have a common difference or a combination. So let's see, from 3 to 5, what did you have to add? I think you had to add a 2 plus 2, right? And then from 5 to 9, it looks like you had to add a 4, right? It's not a 2. From 5 to 9, you had to add 4. And then from 9 to 17, you had to add 8. And then 17 to 33, I believe you had to add 6. Okay. So it looks like the common difference isn't consistent, but I do believe we do have a common difference. It looks like you're doubling the common difference, right? So you are technically doubling your common difference. So what do you think my sixth term is going to be? So it's going to be the last term, which is 33. And then our common difference is doubled. So instead of adding 16, we're going to add 32. So 33 plus 32 is going to be 65. Okay. So that is my sixth term, which is 65. Okay. Sometimes they'll be tricky like these ones where you have to like, even though you may have a common difference, it may not be consistent. You may be doubling, right? They have some weird patterns, so keep note of that. Okay, let's look at question 6. What is the next number in the following series of numbers? Okay, so 0.5 is your first term, 2 is your second, third, fourth, fifth, sixth. You guys somehow find the eighth term. So let's see. Let's see if we have a common difference or some kind of pattern with a common difference. So from 0.5 to 2, it looks like you had to add a 1.5. And then from 2 to 1, it looks like you had to subtract 1. And then from 1 to 2, it looks like you had to add 1. And then from 2 to 2, you had to, okay, so it looks like there is no there's no pattern for a common difference. 1.5, -1, -1 to 1 to 0. No, right? There's no pattern. So we don't have a common difference. Let's see if we have a common ratio. So when I say common ratio, it means a number, instead of adding or subtracting, we're multiplying a number. So from 0.5 to 2, what did you have to multiply? I think you had to multiply by 4. And then from 2 to 1, what did you have to multiply? 0.5. Here, let me write it out here. I don't know, 0.5 to okay. We're dealing common difference. So from 0.5 to 2, it looks like you had to multiply by 4. From 2 to 1, it looks like you had to multiply by 0.5. From 1 to 2, it looks like you had to multiply by 2. From 2 to 2, it looks like you had to multiply by 1. From 2 to 4, it looks like you had to multiply by 2. And then from 4 to 8, it looks like you had to multiply by 2. Okay, so do you see a pattern? I don't really think, well, oh, look. See here you have 0.5, which is related to the first term. And then here you have 2, which is related to the second. And then here you have 1, which is related to the third. Do you see the pattern? It may not be a common ratio, but what so each I think that each multiplication is from the previous number. So each ratio or multiplication, right, is from the previous. So what should be my, let's see, 1, 2, 3, 4, 5, 6, 7. What should be my eighth term? So my eighth term is going to be the last term, which is 8, times it by, so if you look at the pattern carefully, it's going to be 8 times the previous number, so 8 times 4. Okay, so that would be 32. Yeah, this one was a little bit trickier because you had to see the pattern. Let's do 7. What is the next numbers of the following sequences? So here we have 7. So let's see. Here's the first term, second, third, fourth, fifth, sixth. Let's see if we have a common difference or some kind of pattern related to a common difference. So from 7 to 11, I believe you had to add 4. From 11 to 13, I believe you had to add 2. From 13 to 17, I believe you had to add 4. From 17 to 19, I believe you had to add 2. Okay, so I see a pattern. From 19 to 23, you had to add 4. So it alternates of a common difference. You went from 4 to 2, 4 to 2, 4. And then I believe the seventh term is your last term, 23. Instead of adding 4, you want to add 2 because it alternates. So 23 plus 2 is 25. But I don't see 25 as one of our choices, right? So I think you have to keep on going. So this is A8. So A9 is going to be the 8 term, A8 term, 25. But instead of adding 2, you're going to have to add 4, which is 29. Now that is an answer I see as my choice. Wow, that can be tricky. Question 8. Here we have this equation, A equals B plus 3 times C minus 3. If A equals 10 and if B equals 1, what is the value of C? I think the best choice is just to substitute it back in, solve for C. So let's substitute our values. So if A is 10, it's going to be 10 equals B, which is 1 plus 3. And then it's going to be C minus. Okay, let's clean it up. So on the left, it's 10. Over here, I do have to FOIL out this 3. So this is going to be 3C minus 9. And then this one, just bring it down. Okay. And then collect like terms. So you have a 1 and a -9, which is -8, plus 3C. Solve for C, so you're going to add 8. 8. So 10 plus 8 equals 18. Divide equals to 3C, and then solve for C by dividing this by 3. You get 18 divided by 3 is 6. That's, yeah, not too bad, right? And question 9, consider the following formula. AB equals BC plus 2 times C minus 0.5. If A equals 4, B equals 5, what is the value of C? So this one, just like the other one, it's best to just plug in your values. Okay. So that's what I'm going to do. Okay. A is 4, B is 5, and what is C? So on the left, it's going to be 4 times 5 equals B times C. So B is 5. I don't know what C is. Plus 2 times C minus 0.5. Okay. Clean this up. 4 times 5 is 20 equals to 5C. And then 2 times C is 2C. And then 2 times negative 0.5 is -1. Right? Uh, yeah, but you remember you can't use a calculator, so you need to know how to multiply it. 0.5 times 2, which is 10. 2 times 0 is 0 plus 1, and then 1. Yeah, that's how I got -1. And let's clean this up. So 5C plus 2C is 7C minus 1 equals to 20. Add 1, get 21. So 7C. Okay, solve for C, so you're going to divide this by 7. You get C equals to 3. Okay, another one, plugging, substituting it back in. So question 10, we have A times A plus 2B plus 2C equals 11 plus B. If A equals 2 and if B equals 1, what is the value of C? So let's plug it in. So this is question 10. So if A is 2, so it's A 2 times A is 2 plus 2 times B is 1 plus 2C equals to 11 plus B, which is 1. Okay, so what I would do first is remember order of operation pandas. Wait, on the right side, let's simplify the right side. You only have one order of operation, which is 12, which is addition. So pandas on the left side, we must do the parentheses first. And then inside the parentheses, so it's 2, and then 2 times 1 is 2 plus 2C. And then keep on cleaning up the parentheses. So 2 plus 2 is 4 plus 2C is 12. And then FOIL out this 2, so 2 times 4 is 8, plus 2 times C, 2 times 2C is 4C, equals to 12. Solve for C, so you're going to subtract 8, and then 12 minus 8 is 9, 10, 12. 9, 10, 12, that's 4. Divide this by 4, you get C equals 1. Perfect. Okay, question 11. So this is a different problem, different style problem. So we have solve the following system equation. We have x plus y equals 7, x minus y equals 1. So when they say solve the system, they want so what's really happening is these are two linear lines, right? Uh, I'm just making this up. Let's pretend x plus y is a linear line that might look like this. And then the other line, linear line, x minus y, might look like this. I'm just making this up. And then what you're doing is finding the solution or the point of intersection, which is a coordinate. And yeah, so there's two ways you can do this. You can do elimination. So here, let me rewrite it. So x plus y equals 7, and then x minus y equals 1. Okay? I'm doing elimination. And you got to figure out what you got to do is figure out what letter you want to get rid of. And it's probably obvious you can see that the y's cancels nicely. So you can just forget it. The y's cancel. If you add them up vertically, the y's cancels. That's what I'm going to do. The y's cancel. So 1x plus 1x is 2x. The y's cancels, and then 7 plus 1 is 8. Solve for x by dividing both sides by 2. 8 divided by 2 is 4. Okay, then, because we want an coordinate, then what we got to do is find the y. So what you can do is plug in 4 back into either this one or this one. It doesn't really matter. So if I put it in the first one, it would be 4 plus y equals 7. Subtract 4, I can get 7 minus 4 is 6, so that's 3. So my solution is 4 comma 3. Okay, so that would be D. Now, the other choice, if you forgot how to do elimination, or if you forgot how to do elimination, because your choice is multiple choice, what you could do is test each one back into both equation, and if both equation turns out to be true, that's the one. So for example, if we use the point 3 comma 4, put it back into the first one. So my x is 3 plus y, my y is 4. That is 7. Is that true? Yes. 3 plus 4 is 7. This is a true statement. But you got to put it in both equation and they both got to be true. So put it in the second one as well. So my x is 3 minus my y is 4. Oh, we got a problem. 3 minus 4 is -1. That's not true. So yeah, and then if you try the second one, which is the one, right? It would be 4 plus 3. That's 7 plus 7, definitely true. And then second, if you put it in the second one, it would be 4 minus 3. Yes, that's definitely. Okay. So that's another, so it's definitely B. So that's another way you could do, just because it's a multiple choice, just plug it back in, etc. Okay, this one solve the proportion. So this is question 12. So as you can see, we got to solve for Z. That's what they really want. And we have two sides, the left side and the right side. So you can cross multiply if you only have two sides. But before I cross multiply it, what I'm going to first do is simplify the denominator. Okay. So looks over here we have 6. And then on over here we have 2Z plus 3. That's all